Okay, well, the next couple are pretty easy, so I'm just going to do one video for quite a few. So we're just using the basic differentiation rules, so I'll just mention them. So y equals 8, so y prime is equal to 0, because the derivative of a constant is 0. The derivative of 10 would be 0. The derivative of a million would be 0. Okay, 6, y equals x to the 8. So this is a power function. So when you take the derivative of power, it says that the derivative is equal to the exponent 8 times x to the new exponent, which is 1 less.
Okay, this is problem 6. So we got y is equal to x to the 8th. So this is just a simple x to the n problem. Y prime is 8x to the 7th power.
Okay, then we have x is equal to 1 over x, pardon me, y is equal to, here's still y is equal to 1 over ex to the 7th power. So when we have situations like this, we always want to move the exponent to the numerator, which means that you change the sign. Now you just have it in the same form as this. So when you take the derivative, you get negative 7, which is the old exponent, times x, and subtract 1, so it would be x to the minus 8. And typically we don't like to leave it with this in the numerator, so you get negative 7, move it back to the denominator, and you get 7 over x to the 8th power. Okay, what do we got now? 10. 10, yes. So we have g of x is equal to the 4th root of x. Again, we have to get it in a form like this. Either if it's in the denominator, we move it to the numerator, make it the opposite sign. If it's a root, then we just use the equivalent expression. So it's x to the 1/4 power. So the square root of x is x to the 1/2. The cube root is x to the 1/3. I don't know what you call the 4th root. Special name, but anyway, it's x to the 1/4. So now it's power rule. So n is equal to 1/4. So when you subtract 1 to get the derivative, you take the old exponent, which is 1/4, and you take 1 less than that. So we take n minus 1, which is negative 3/4. So that's x to the negative 3/4. Okay, we'll stop there, and then we'll go to the next group. So let's continue on with problem 11. F of x is equal to x plus 1. So if you have a composite function that's made up of two functions that are added together, you just take the derivatives of the individual functions separately. So we're going to take the derivative of this, and we're going to add it to the derivative of that. So the derivative of x is just 1. If you treat it as a polynomial, it would be x to the 1st power. So when you take the derivative, you'll get 1, the old exponent, times x to the 0 power. And any number or any variable to the 0 power is 1, so you just get 1. And the derivative of a constant is 0, so the answer is 1. Okay, y is equal to t squared plus 2t minus 3. So we're just adding one more term. So the derivative, take the exponent from the original function, multiplied by t to the 2 minus 1 power, which is 1, plus 2 times the derivative. This is a product of a constant times a variable. So you take the constant, just bring it down, and then you multiply by the derivative of the variable, which is 1. And then the constant, the derivative of a constant is 0. So our final answer is going to be 2t to the 1st power, not t prime. So just 2t plus cubed.
Okay, problem 14. Y is equal to t squared plus 2t plus 3. So we have the sum of three polynomials. We just take the derivatives of them individually. So the derivative of t squared is 2t, the derivative of 2t is 2, and the derivative of 3 is 0.
Okay, next is 15. G of x is x squared plus 4x cubed. Again, we have a sum of two terms. Take the derivative of a sum, it's just the sum of the derivatives. So we can say that g prime of x is equal to the derivative of x squared, which we just did. It's 2x. 2 comes down. X to the first power is just x. The second one, we have 4 times the derivative of x cubed, which is 3x squared. 3 comes down. Reduce the exponent by 1. And then you want to clean it up, and you get 2x plus 12x squared. A lot of times what people will do as a shortcut is just say, okay, I'm going to take the exponent multiplied by the constant, 12. Reduce the exponent by 1. Okay, let's do one more in this section. Number 18. It's a polynomial made up of 3 terms, and we do each one separately. So the derivative of the function. We take 2 times the derivative of x cubed, which is 3x squared, minus derivative of x squared, which is 2 times x to the 1 power. And you don't need to carry it. If you understand it, you don't need to carry the 1 power. I'm just doing this 2. And I guess that was 3x up there. So you get 3 times the derivative of x, which is 1. So we get 6x squared minus 2x plus 3. The quick way would you take 3 times 2 is 6. You have x squared left. 2 times negative 1 is negative 2 to the first power, which is x, plus 3 times derivative of x, which is 1. Okay, we're going to bunch some of these together. So here we'll have y equals pi over 2 times the sine of theta minus the cosine of theta. So the derivative of the sine is the cosine. The derivative of the cosine is negative the sine. So when we do this, we do them separately. So we have our constant, which is pi over 2, times the derivative of the sine, which we know is the cosine. And then we have negative the derivative of the cosine, which is negative of the sine. And we just cleaned up a little bit. Pi over 2 cosine of theta plus sine of theta. 22. We have y is equal to 5 plus the sine of x. So we have a trig function and just a constant. So the derivative of a constant is 0. The derivative of the sine is positive the cosine. So the answer is cosine of x. Y equals 1 over x minus 3 sine of x. Now you might be tempted to find a common denominator, but it's just easiest to do these separately. The first term we're going to rewrite as x to the minus 1 power. How did I get that? Well, it's implied that this is x to the first power. So x by itself is always x to the first power. So when you move it to the numerator, you change the sign. So again, because we're adding or subtracting these, we just do them separately. So I have to put the, actually, I don't need to do that because that's not the derivative yet. That's just fiddling around. Okay, so now the derivative, take the exponent, y at x to the minus 2 power. So we're subtracting 1 from -1, you get -2. The second one is the constant, and then you take the derivative of the function, which is the cosine of x. You move this to the denominator, so you have -1 over x squared. So here it's -2. Move it to the denominator, it becomes +2. And then you have 3 cosine of x. That's your second term. And the last one in this grouping is 26. So the next few, well actually just this next one, when you have a fraction, just like we just did briefly here, so we're looking at 26. So we have y is equal to 2 over 3x squared. So first thing we say is rewrite. What rewrite means is you have to move the variable term to the numerator and change this sign. Now we don't need to fiddle with the constant because we're not taking the derivative of the constant. The constant just kind of hangs along. So now we've rewritten. The second one is differentiate. So if you have a constant times a function, it's the derivative, it's the constant times the derivative of the function. So the 2/3 just stay out there, and then you have the exponent, which is -2 times x to the -3 power. So we decrease that by 1, and then we multiply out. So you get -4/3 x to the -3. But we don't like to have negative exponents in our final answer, so it becomes -4/3 times 1 over x cubed. Or we could say it's, okay, now moving. Okay, here's some problems I forgot to include originally. So we have y is equal to the square root of x over x. So you just simplify that. That's 1 over the square root of x, which is 1 over x to the 1/2 power, which is equal to x to the -1/2 power. So we simplified it, change it to fractional exponent, move to the numerator. So when you take the derivative, you get -1/2, which is the exponent times x to the -3/2 power, by decreasing that by 1. And then you move the x term to the denominator, and you get that. Now it's a quotient. You could use the quotient rule, but they're just telling you to simplify it and then rewrite it appropriately. Okay, the next one I didn't do was 32. So it's saying we have f of t is 3 minus 3 over 5t at 3/5, comma 2. So they're asking to find these, find the slope of the graph of the function at a given point. So they're not asking us to find the equation of the tangent line. So all we have to do is to take the derivative. Before we do that, though, we're going to rewrite the second term as 3/5 times t to the -1 power. And now we can take the derivative. So the first term is 0. The second term, we've got -3/5, and you multiply by -1. You change the exponent to -2. So the 3/5 becomes positive. The -3/5 becomes positive. And then you can move the t to the -2 power to the denominator. So we can have 3 over 5t squared as the answer. And I'm just going to check the answers in case I don't want to make any mistakes, even though I feel pretty confident I've done this correctly. But I do make mistakes. That's hard to believe. Okay. Okay, so the first one's correct. Oh, I didn't evaluate it. I just said what it was. Okay. So now we want the value of the derivative at x equals 3/5. So we'll have 3/5 times 1 over 3/5 squared, which is the same as 5/3 squared. So you can take the reciprocal of that and multiply it by the original term. So one of these 5/3 is going to cancel out with one of these 3/5, and then there'll be one left. So the answer is the value of the slope of the tangent line at x equals 3/5 is 5/3. Okay. Number 35. Now we don't know how to, there's another way of solving this using what we call the chain rule, but at this point we don't know the chain rule. So to solve this you have to multiply out this expression. So when you're squaring something, that's what you're doing. And now we use FOIL. Okay, so now we can take the derivative easily. So that's the equation for the derivative y prime. So y prime at x equals 0 is just going to be equal to 4 because the first term drops out. It goes to 0. Okay, so that's going to 39. So we just have to find the derivative of the function. It's just not really that much more complicated. It's just got more terms. So the thing is, you just have to look at each term separately. And this one's already set up so that the exponent is in the numerator, term in the numerator. So I don't, this is really -3 over x squared. Anyway, so we just use the power formula. So you get 2x plus 0, derivative constant 0, and then you have -2 times -3, which is +6, and then it's x to the -3 power. Reduce that by 1. And then I probably would write this as 2x plus 6 divided by x cubed. Okay, the next one is 42. So we get f of x is equal to x plus 1 over x squared. What we would do is we would rewrite this. The first term doesn't need to be rewritten, but the second term needs to be changed into a negative exponent in the numerator. And then I take the derivative of each term separately. So the derivative of x is 1, and then you get -2 times x to the -3. This comes down, decrease the exponent by 1. So you get 1 minus 2 over x cubed. 43. F of x equals x cubed minus 3x squared plus 4, all divided by x squared. You said, I haven't done anything like that yet, but because we only have a single denominator, then we can just divide each term by x squared. So x cubed divided by x squared is x. -3x squared divided by x squared is -3. And then we have 4 divided by x squared. Then before we take the derivative, we want to convert that third term into 4 times x to the -2 power. We take the derivative. The derivative of x is 1. The derivative of a constant is 0. Here we get -2 times 4, which is -8. We reduce the exponent by 1. So the final answer is 1 minus 8 divided by x cubed. Now, I'm just going to go one more step here. If you find a common denominator, so if you multiply this by x cubed over x cubed, you'll get x cubed. The second term is 8, and the whole thing is divided by x cubed. And the last one in this sequence is 46. Again, this looks different, and in the next section we'd be able to do this differently, but at this particular point we have to just use the brute force method. So what that means is you just have to multiply everything out. So you'd have 3x times 6x, which would be 18. 3 times 6 is 18. X times x is x squared. And you'd have negative 5 times 3, which would be negative 15. X times x squared is x cubed. Okay, so now we have polynomials, so the derivative, just do each one separately. 2 times 18 is 36. Decrease the exponent by 1. 3 times 15 is 45. And we decrease the exponent by 1. And that's your answer. Problem 57 and 60 are the same kind of problem. And they're asking us to determine the point or points, if any, at which the graph of the function has a horizontal tangent line. So horizontal tangent line, horizontal means slope equals 0, which means derivative equals 0. So all we have to do with these problems is take the derivative, set it equal to 0, and solve for the values of x where it goes to 0. So for this function, we take the derivative, and so the derivative of x to the 4th is 4x cubed. 4x, reduce the exponent by 1. Okay. 2 times 8 is 16. Reduce the exponent by 1, which is just x to the first power. And then we have 0. Okay. So then you set that equal to 0. 4x cubed minus 16x is equal to 0. And you solve for the roots. So you don't want to divide by x. You want to factor out an x. And we'll actually factor out a 4x. So we'll get 4x. That'll leave x squared left here. And 4 by itself. So if you multiply back out, you get 4x cubed. 4 times negative 4 is 16 times x is 16x. Okay, that's equal to 0. And then you factor. Now you can divide by 4 because that's just a constant. So let's get rid of the 4. You can't divide by x because that's the solution. Then you have x minus 2 and x plus 2. So you can see there actually are 3 places where you have a horizontal tangent line. X equals 0, x equals 2, and x equals negative 2. So likewise, problem number 60, we have y equals x squared plus 1. So we take the derivative, you get 2x. Set that equal to 0, 2x equals 0, x equals 0 is the solution. So you have one horizontal tangent line. And that's at x equals 0. All this function is, if you remember, it would be a parabola with an intersection at x equals 1. So it looks kind of like this. Y equals x squared looks like this, so it's just shifted up by 1. So you can see it has a horizontal tangent line here at the bottom. And I'm going to go ahead and just do the last one here, 93, I read it. Actually, I'm going to do that separately. Okay, next wood problem, 92. Okay, so we're back to 93. It says in exercises 93 and 94, use the position function s of t equals negative 16 t squared plus v0, which are physics friends now means the initial velocity, and S0 means the initial position. So the silver dollars drop from the top of a building that is 1,362 feet tall. Determine the position and velocity functions for the coin. So one thing you actually have to do is you have to define where x equals 0 is. So this is my building. It's not a graph. And so we know this height here is 1,362 feet. So if I chose my coordinate system to be here, t equals 0, so s, you could have s of 0 equals 0 feet, and then the final condition would be, when it hits the ground, is s at some time is going to be equal to negative 1,362 feet. That would be one way of doing it. Or you could have S0 equal to 1,362 and S equal to 0, where you'd use this as your basis. And it doesn't really matter which one you use. So let's choose x equal, let's choose it here. We're going to do the second one. Now, what's the initial? This is the initial velocity, and because it's being dropped, drop means you just let go, then that means v0 equals 0 feet per second. So even before we start, our function becomes negative 16 t squared plus 1,362. Because that's S0 is 1,362. Okay, so that's the position. The velocity is equal to the derivative of the position expression. So you get negative 32t. So when t equals 0, velocity is 0, and as t goes more than 0, it becomes velocity is negative because it's going down. So anyway, that's the velocity. Determine the average velocity on the interval from 1 to 2. So what is the average velocity? Well, it's just there's two ways of doing it, really. There's the average of the velocities, and there's the average velocity. It turns out the average velocity is going to be the position at t equals 2 seconds minus the position at t equals 1 second, divided by the time difference, which is 2 seconds minus 1 second. So let's just plug them in there. So the average velocity is, if you plug 2 in, you'll get, let me get my calculator out. So you get negative 16 times 2 squared plus 1,362. So you get 1,298 feet. And then if you enter 1 in instead of 2 into the equation, you get 1,346 feet. So those are both feet. And you divide by 2 minus 1 seconds. So the average velocity, 1298 minus 1346 divided by 1 is negative 48 feet per second. So that's the average velocity. It says find the instantaneous velocities at t equals 1 and t equals 2. So I'm going to just plug 2 into this equation. So you'll have negative 64 feet per second, and at 1 it's equal to negative 32 feet per second. Just plugging t equals 2 and 2 and 1 into there. And you see the average is 48. If you take the average of these two, it's also 48. So it turns out the average velocity is the same as the average of the velocity. So we could say average, I'd say not the average velocity, but the average of the velocities. In this case, in for constant acceleration that the average velocity is just the average of the velocity. So our average velocity is equal to the average of the velocities. So we take v of 1 plus v of 2, and we divide by 2. And you can see average of those two is negative 48 feet per second. That only works out for constant acceleration, which is the case. Okay. Find the time required for the coin to reach the ground. So to find the time, you go here because we're going to solve for S. Find out, we're going to put 0 for this. So you can say that the height is 0, which is the ground. And then we solve for the t, which made that happen. So you'll get 16t squared is equal to 1362. So we divide both sides by 16. 1362 divided by 16 is 85.1, let's say. Make sure that's right. 1362 feet. And 16 is the coefficient. Something's wrong here. No, that's right. Okay, and then we take the square root. Raised to 0.5 power. That's the wrong thing here. So let's try this again. 1362 divided by 16 raised to the 0.5 power, 9.2. So the answer is 9.2 seconds to hit the ground. Find the velocity of the coin at the impact. So once you have the time, then all you have to do is go back to the velocity equation. So the velocity at 9.2 seconds is just negative 32 times 9.2 seconds times negative 32, and I get negative 295 feet per second.